Okay, guys, let's get started. We are on triple integrals, and in this particular one, version 4, we're going to find a triple integral over, guess what, they're changing the letter because they feel like it, of that function. And E is the enclosed by two surfaces. E is got z equals x squared minus 1, and then z equals 1 minus x squared. Can you pretend I actually know what those guys look like? But that could be the top half and that could be the bottom half. So when you put that together, you've essentially got this three-dimensional surface, and it's inside that. Now, what does that tell us about how to set up this thing? Well, we need to have limits of integration, essentially. We need to know what these look like. Now, I have this guy, and I have this guy, and I got to figure out who's the big guy and who's the little guy, because I could switch them around. And if I switch them around, it means my answer will be negative rather than positive. So it's not the end of the world. So if I plug a random guy in, oops, I'll put that one in there, that one in there, and I'm just going to do it because of the order they told me.
What is the x squared minus 1 and the 1 minus x squared? When does the
Oh, sorry. Yeah. Let me start again. I said the right answer. I put it in the wrong place. So imagine I had it. So that's finished thing that's coming into my head. So they're telling me that it's x squared minus 1. So I'm going to assume it's from there to there. Now I've got these two surfaces to deal with. And so the region E that they're talking about is formed by these two surfaces meeting. And I'm assuming that they're going to meet in some way that I can figure out what the heck they are. Oh, and they've got some other things I haven't written down yet. They've told me that y equals 0 to y equals 8. Ah, well, that's good. I now know what the y's are. I have a problem with the x's right now. The only information I've got is these two surfaces. And somehow that's going to come up and give me a range of values for the x's. How do you think I might figure that out?
Set them equal to each other and solve. There should be 2 points of intersection, one negative, one positive, because you'll get a square root.
And that's how we did it. So the information was two surfaces, some y values that you're told, and some unknown x's. The z's I got because they told me them. The y's I got because they told me them. And the x's I got by finding what the interaction is. Can you imagine there may be another world that looked like this?
How did you get y is going from 0 to 8?
Because they told us in the question. So the question told me y was from 0 to 8, so that's why I used it.
Okay.
Right. Let me check my brain here if I can. There we go. Suppose I had this surface meeting up with that surface, right? Then my z's would go from negative x squared, negative y squared plus 9, and they start at x squared minus y squared. Now, if I set those two equal, and I've done this question, I hope the right way around, you get x squared plus y squared is going to equal negative x squared, negative y squared plus 9. And that's going to be 2x squared plus 2y squared equals and make that 18. Yeah, just to make the numbers come out nice. Equals 18. So I now have x squared plus y squared equals 18. Can you see in this second story, the connection between x and y ends up being just a circle? And the circle would be 9. So I would probably think about doing, instead of the ranges of x and y, I would be thinking of doing an r and a theta. And what about the z? Leaves the z's alone, they're fine. So you can do polar in 3 dimensions. All you need to do is the x's and y's become r and thetas and the z's stay as z's. Can you imagine that situation? So if the information comes up that way. Now I've made a whole load of different running around here, so let's return back to this question. We're being asked to find the triple integral of x take away y dv over a region E, and we know that the x's go between 1 and -1, we just found that. We know the y's go from 0 to 8 because they told us, and the z's go from 1 minus x squared, is it? Go from x squared minus 1 to 1 minus x squared. Right, so should be able to set that up. It's going to be from x is -1 to x equals 1, from y equals 0 to y equals 8, and from z equals 1 minus x, I go again, 1 minus x squared to x squared plus 1. And then you do an x minus y dz first, dy next, and dx. Can we leave that question at that point? Isn't it pretty much the hard part's done, it's set up? Just by looking at these things, aren't you just going to be dealing with polynomials, x cubes and x squares and stuff? It would take me about 10 minutes to go through it. It's not hard, it's just long. So there's a little messy one to start with. And again, I'm only going to start this one up. We're doing a triple integral over a region E, and the function is just y dv. And we are told E, this is what it looks like. There's your x's. There's your y's. And there's your z's. Which one of those 3 is going to be the limits of integration for the inside one? The one that's going to get written here.
We're going to do a dz first.
And that's going to be from z equals x, take away y, to z equals x plus y. Why did you choose that and not one of the other 2?
Because there's 2 functions.
2 variables, right?
Yep.
Agreed.
And then the second integral would be y.
And when you look at the choice, do you see why you choose y and not x in this story? Right? The y has an x in it, so that means that we're going to do a y equals 0 to y equals x, and then obviously whatever's left, in this case it's dx, goes here, and it goes here. Now in this particular question, the x, y's and z's were given to you, but that's not the reason it's x, y, z. I mean, couldn't I do x from z plus 1 to z minus 1, and y from z plus x to z squared minus sine x, right? And then just do z from 0 to 2. Couldn't I just, the limits integration could be anything. So although this one kind of went out alphabetically, which is nice, it's not because they're alphabetical that I did them in this order. Wasn't it because most variables, less variables, no variables? That's the order. Are we comfortable that this would just be one big ugly polynomial, long but not difficult? Are we good at leaving that one? Good. So let's move on and do a this is a version of 6 then. That's the guy we're going to do. You have a cylinder called y squared plus z squared equals 9. And you have an x equals 0. You have a y equals 3x. And you have a z equals 0. And everything is in the first octant. That has to generate my limits of integration for x, y, and z. Okay, we got to figure out how to take all of this information and kind of make sense of it. Okay, let's take this piece of information since it was given first. Now, if I rearrange that, won't z be the square root of 9 take away y squared? Now, technically, couldn't it be plus or minus? But see this piece of information here? And it's in the first octant. Oh, I haven't talked about the first octant before. If you think of your 3D space, remember the first, second, third quadrant. You know, when you're doing X's and Y's, first, second, third, fourth. Remember those guys? They were sometimes helpful. In this case, octant is because if you take 3D space, can you imagine that you make 8 regions? 8 for octant. Now, the first octant is actually, I'm not sure if I can draw it, but I'll try. It's that one there. Would that make sense that the first octant would be when everybody is positive? And then you count octants by going 1, 2, 3, 4, and then you go underneath 5, 6, 7, 8. The chances are, if they mention an octant, it's going to be the first octant. Now, if you're in the first octant, doesn't that essentially mean X, Y, and Z are all positive? Which is why I'm choosing that. Now, what is the other Z value then? Because I need a start and a finish, don't I? What's the other Z?
0.
0. So as I find them, I'm going to put them in. And so I have got right now a Z equals 0 and a Z equals the square root of 9 take away y squared. And I'm putting 8Z there and I'll do a DZ. So I'm happy with that one. Okay, now, where are we off to next? Well, how about this one? Wouldn't y be equal to 3x? Wouldn't that be one of the limits of integration? What would the other one be? Because I need a start and a finish.
Would it be 0? Since we're the first octant, so it can't be negative.
Yeah, so it's 0 because of this guy. So y equals 0 to y equals 3x. And then I'll do a dy. Now, the one that's missing is the x's, right? So I know that y is going to be 3x and the other end at 0. But the x's are sort of a missing. Well, one of them's not. Would you agree x equals 0? So I know I'm going to go here. But what number, because that must be a number, right? The last one has to be a number. What number is that?
Is it the radius of 3?
Oh, because of here? Is that what you're thinking? Yeah, it can, yeah. Unfortunately, it's not, but that makes perfect sense why you might think that.
Do we like plug in the functions we have for y and z? So first, like plug z, put take z, which is root 9 minus y squared, substitute in 3x for the y there, and then take that whole thing, substitute in for z, and then take the original y function 3x and substitute in for y. So you get like 9x squared plus 9 minus 9x squared equals, no, that just proves 9 equals 9. Never mind.
Yeah, no, it was good thought process. I'm looking because I can see the solution over here, and I'm looking at the answer, and I'm trying to find out in my own brain why it's 1.
It's too bad we can't separate this one. I know we can't because we have functions in our limits, but if we could separate this one, it would be beautiful.
What, it would be a very simple expression. I'm not sure that 3x would screw it up. Right, so I'm looking at this guy and they're telling me it's x equals 1. And I don't know yet why that is. So if I draw y equals 3x, it looks like that. And I can understand the 0 because they told me it. But according to them, it finishes at 1. So got to figure out where that comes from. Right, I'm going to show you the solution that I'm looking at. And maybe it'll come to you.
I was seeing on the triangle that it was so you had the equation y equals 3x.
Oh, darn it. Yeah, okay. I'm slow, but sure. If you take the z equals, and it was kind of connected to where you were thinking, so you're on the right tracks. This guy is 9 minus y squared, right? You've got this guy here. Right, if you make z 0, isn't that the ground? And that makes y equal plus or minus 3, right? So far, so good. And since you can only do 3, that makes y 3. So that tells me that this has to finish at 3. And if this finishes at 3, does it not make x 1? God, that was a hard one to find. That's why that is 1. Actually, that's the hard bit over, isn't it? Right. Saying, oops, I forgot my dx. Thank you. Right. That was a cool question. And I had the answer in front of me and it still didn't make sense. But you know, sometimes knowing the answer doesn't tell you where the answer came from. So that doesn't help too much. All right.
Yeah, but sometimes it can help you find out why it's the answer.
Yeah, you at least I knew what the number was, and then I had to be able to figure out what that number, how it became that number. Okay. It's just basically setting these guys up, because the setting up is the hard part. I think the integral that you get left with isn't necessarily too scary. So we have a one like this, and the region E is described as the plane, which is this guy. It's above the XY plane, which is basically means that that's the other Z guy. Now, if you tell me you're above the XY plane, you're telling me that. So I've already got my Z guys. That's good. I know that Y equals the square root of X because they told me, and Y equals 0. Oh, that's a freebie. Don't have the Y's then. And we have an X equals 1. So all I need to do is figure out who the other X is, and we are good. Right. So the integral is going to be from Z equals 1 plus X plus Y. No, it isn't. 1 plus X plus Y goes up here, and Z equals 0 goes there. And so that's the Z's done. I got this fella here, which kind of takes care of that guy, right? And that's the Y's done. And all I need to do is find out who the X's are. And I know that X equals 1, and I have to get this number. And I now know what that number is. Does anyone else know what the starting value of X is based on all this stuff going on here?
I would assume that it's 0 because
You
I would assume
are.
that it's in like the first block.
Now, if you take this curve, Y equals the square root of X, it looks like that, right? And if you tell me Y is 0, aren't you also telling me at the same time X is 0? and you're told it finishes at 1. So there we go. Horrible, well, not that horrible, but big. Integrate with Z, plug these in, integrate with Y, plug these in, integrate with X, and you are good to go. And this one is Z equals, well, actually, let's write it down the way they gave you it. It's 9x plus y plus z equals 4. It says the tetrahedron. So if you take this guy and you imagine it in 3D space, you get a diagonal plane crossing like this. And so the tetrahedron you're going to get will basically be this fella here. Can you imagine the tetrahedron that you would get if a plane just kept on going? Wouldn't it cut the x, y, and z axes at different points? And the triple integral that we're getting from here, if I now rearrange it, you get 4, take away 9x, take away y. And the ground is called z equals 0. So I have already set up the limits of integration for that guy. And you might be thinking, what function goes here? 1 goes here, because we're actually going to be finding the volume of this tetrahedron. And a triple integral gives you the volume of a region, in this case, the tetrahedron, if you plug a 1 in there. Now, that's dz done. Now, the x's and y's are going to come from that triangular region below. You see that little triangle that would be formed here? If you take this equation, right, this one here, and you rearrange it by making z 0, you get the equation of that straight line. Do you see how I, oops. You see how I found the equation of that straight line? Now, if I draw it sideways, it looks something like this. And I'm going to create this triangular region by doing those fellas. So that tells me that y is going to go from 0 to the top, which is y equals 4 take away 9x. Now, all I need to do is figure out one more thing. What are the x's going to be? So this little triangle is him, and I need to describe this region. What will be the start x value to create this triangle?
It'll be 0.
Right. Now, what number will that guy be? Basically, don't you solve with what makes that 0, right? So what
4
number?
9ths.
So 4 9ths or 9 quarters? Which one? Four ninths?
I think it's 4 9ths.
You're right. Okay, and there's my dx. And if you take that triple integral and you integrate it with 1, then you get the volume of that tetrahedron shape. If you notice, today has really been about finding the limits of integration on regions that are getting kind of, well, it depends which one we talk about, are getting kind of uglier and uglier and uglier, right? Okay, so this is a version of 9.
Professor.
Yes.
For that last one, can you just plug, like if you make X and Y 0, can you then find, like, do you have to use the equations or can you just find the numbers for each?
Yeah, you're just finding intercepts, so you can do it that way. And if I'm picking you up right, you're just saying, look, what makes that 0? That makes that 0. What happens if you make, for instance, if you make Y 0, do you see you get the 4 minus 9x? Is that what you're thinking, Patrick?
Yeah, I was thinking like when both X and Y are 0, then Z would equal 4. Right?
Yes, so that would give me the coordinates of that point.
So then could we just do the triple integration with just numbers instead of the
Oh,
equations?
a 0 to 4. No, because what you would be finding is the volume of a box. If you look at that little tetrahedron, if you choose a point on the surface and it goes down to the ground, that is a typical, oh, it gets really weird because you have to do it in 3 dimensions now. Can you imagine a little square pencil rectangular box? The Z value goes from the surface, which is here, to the ground, which is here. So that needs those numbers.
Oh, gotcha.
And this triangular floor, which is basically this guy, has to have a rectangle in 2D. So in 3D, it's a little rectangular box, vertical height to height. And then when you do these guys, it's kind of flat rectangle. Not that you want to do it, but do you know if you do a fourth variable, fourth dimensional integral, theoretically, the thing that you're measuring is a fourth dimensional cuboid, I guess you'd call it. Hypercube. They're always called hyper when you stick them the next dimension up. Oh, that was a brain teaser. Right, who we got this time? We're asked to find the volume of a solid. So that tells me I'm going to do the triple one of that. And the region E, well, it's described as the solid enclosed by 2 curves, and 2 surfaces, I should say. So we have that guy, and that guy. So if I was looking at that, this would be a surface instead of like top piece, right piece, top piece, bottom piece. It would be right hand and left hand. So you imagine 2 surfaces coming together in the y-axis direction. Now the good news is that these give me the guy that goes here and the guy that goes here. And there's my 1, and there's my dy. So I've done the y's first. I still have to figure out the x's and the z's. What do you think I'm going to do to figure out how the x's and z's interact using only these 2 things? Because that's all they're giving me. How would I find the range of x's and the range of y's using only these 2 guys?
Well, I would start by graphing them, probably in Desmos, and then see if I can make from that what the boundary should be.
Right. The problem if you do it in, well, Desmos is more 2D. If you're doing a 3D one, the 2 regions blend. And so it's kind of hard to visualize them. But what I can do is, can't we do this? Essentially, since y is equal to both, won't they intersect here? Now, if I rearrange this, don't you get 2x squared, 2z squared equals 16? And doesn't that become x squared plus z squared equals, is that 8?
I think x squared plus z squared equals 16.
Oh, I went and halved it. Yeah, I did too much in my brain at the same time there. which is a much nicer number. So if you were looking at what this shape looks like in the XZ plane, don't you basically get a little circle of radius 4? Okay. Now you want to describe that relationship. Would you agree that if I try to just do it in terms of X's and Z's, it would be really ugly square roots, which would be really horrible to integrate? But I could do this in polar, couldn't I? Now, normally when you did polar, you had an X-axis and a Y-axis, and there would be a circle, right? And wouldn't you do R equals, well, 0 to 4? And then won't theta go from 0 to 2 pi? You agree? Do you think that's really going to change much if the circle is not on the XY plane, but as it is here on the XZ plane? Do you think the relationship of generating all the points inside that circle are going to be any different? And the answer is no. That's not going to be a big issue, right? But you are going to have problems back here. But let's not worry about them for a minute. If you want to do, and what I just said, R goes from 0 to the radius, which is 16, and theta goes from 0.
Is 4.
Thank you. It's 4. 16 is a number, 4 is a radius. And that means I can do a D, an R, a dr, and a d theta. But here we have a problem with mixing and matching. These have X's and Z's in them, but no more X's and Z's. So how are we going to fix this?
Can you change the negative x squared minus z squared to negative r squared?
You nailed it right on the ball. And won't the other one just be r squared? So this is the end. It's okay to use X and Z, X and Y, even Y and Z in polar form. Aren't you just going to eliminate 2 variables and convert them into R's and D's? And then the other variable is whatever it is. But whatever the other variable is, don't you have to use R and thetas, at least in its limits? Although you don't know it, we've actually just did a question that comes next. It's called cylindrical coordinates. And that's what you call a coordinate system, where you typically make Z whatever it likes, but the X and Y are written in polar form. I get time for this one. 10. It's a triple integral. It's a volume again, so it's going to be 1. And the region E is described as enclosed by a cylinder, y equals x squared, a plane z equals 0, and another plane y plus z equals 1. So somehow or other, all of this, right, is going to generate the limits of integration. I'm going to use those 2 guys. If I rearrange this one, don't you get z is 1 minus y? And if I leave this one alone, z equals 0. Do you see I've found the limits of integration for the z's? So it's going to be from z equals 1 take away y to z equals 0, 1 dz. There's the z's done. So far, so good. Where are we off to now? Do you think it's limits for y or limits for x's? What do you think I should do next?
You should do the limits for y because you can rearrange c equals 1 minus y to be y equals 1 minus c.
Oh, and use this again? I
Yep.
got you. I don't want to do the second part. I like this bit, but I don't like the second part, because if I introduce a z here and I've already integrated with z, isn't that a bad idea? Because variables should go away. So we're going to take your idea, but just take it a little bit differently. If z is 0, won't that make y equal to 1? So I'm using that piece of information to figure out who y is. Are you comfortable with the y equals x squared to y equals 1? Now, I have to put some numbers for the x's. Well, if I draw my little guy and I have y equals x squared, which I do, and I already know that y equals 1, don't I indirectly also know that x is 1? And I made a mistake. Also, -1. There was no indication that I had to stay inside one of the quadrants.
For your integration bounds of y, shouldn't the x squared be the lower bound?
And I agree with that. The good news is, if I'd left it the way I'd set it up, wouldn't I end up with -50 as a volume? And then realize one of my limits of integration was back to front. But all I would do there is go, oops, and change it to 50, and everybody was helpful. Now, if that happened in a test, I don't want you to go the entire integral from start to finish. If you know that the only thing is one of my limits of integration was back to front, you simply just say in the next line, so volume equals 50, and call it good, right? In the same way that if you know you're calculating a physical area and the answer ends up being -20, won't you realize that you've probably got a limit integration back to front and just call it 20? Now, if there's something else wrong, that's different. But if that's the only thing that's wrong, that's easy to do, right?
So
Yes.
when we do find, if you do get the limits backwards, I have not done enough of these to know this for a fact, but are they always just inverse of each other? So like, is one always?
Yeah, I mean, if the only thing that's done is these get switched around, any one of them, right? The answer will be the opposite sign of what it should be. If it's a volume question, then it will be negative instead of positive, right? If it was just a triple integral that had no connection to reality, right? No connection to a physical thing, then you could get a positive answer when you should have got a negative, or you could get a negative answer when you should get a positive, right? The number will be the right number, but the sign will be wrong. You won't know that when you do just a normal triple integral.
But if it's going to be a volume or on
If
a
it's
double
going to be a
integral
volume
surface
or
area.
an area, you know it must be positive.
Okay.
Right. If you're really lucky, you screw it up twice and they cancel each other out, and you get the right positive answer.
Even better.
But I wouldn't put that as a strategy. Where are we off to? Okay, yeah, got time for this one. In this question, we are going to be given a triple integral. And it's given in terms of y equals 0 to y equals 7 minus z. And then the middle one is from z equals 0 to z equals 1 minus x. And at the end, the x's are from 0 to x equals 1.
So the symbol just one, because you didn't put anything after the dy dx.
Sally, I'm not quite hearing what you said there. Could you repeat it, please?
Oh, so is this just integrating one again because there's nothing before the dy dz dx?
Yeah, that's, if they don't write anything, the convention is that there's one there. Yes. Now, in this question, we're not actually being asked to find the integral, which is strange. But we are being asked to describe what does that look like in 3D. That's a bit of an interesting puzzle. So oops, wrong direction. Should have started with that and make these dotted. So I have an x-axis, I have a y-axis, and I have a z-axis. And what do I know? I know that x goes from 0 to 1. So whatever this shape is, it starts at 0 and it finishes at 1. Agreed? And then if you do this, which is what? Z equals 0 and z equals 1 minus x. If you imagine the xz plane, you see the xz plane here? Right? Now, when x is 0, won't the z be 1? So that means I know it's here. And so I'm going to draw this little triangle. And then what do I know? I know that y goes from 7, take away z, and 0. Oh, so I know that this shape is in here. And I know that y equals 0, so that's the origin, that's not much help. And what about this fella? What I'm trying to do is, can I find where on the y-axis, what number on the y-axis, this shape is going to come down on?
6.
Is it 7? Because z is 0.
You nailed it. If z is 0, you get 7. So if I join this guy to here and this guy to here, and I'm not going to shade that in because it's a mess already, but can you see a tetrahedron? Right, this shape is a tetrahedron. So you go through the things and it tells you what kind of base does it have? And the answer is it has a triangular shape on the XY plane, a triangular shape on the XZ, and a triangular shape on the YZ. And if you put all those things together, you can draw a tetrahedron. They've actually got one here. I don't think I've drawn a very good one, but never mind. At least I